Okay. So what is the formula for a standard scalar? It is a simple x minus mu upon sigma. Sigma is your standard deviation. This is the mean, and this is your x point. Means if suppose this is your data like 10, 20, 30 and 40. So x is your 10, mu is the mean of that. So 40, 30, 70, 20, 19, 100. 100 divided by 4. So this is 25 divided by, so whatever the standard deviation will come, that standard deviation I will put it here. So this is the value for this. So the same way for this, for this, for this. So this is the way. Why I'm doing it after the train test split, I will come on that. And now, what is for the categorical? I had said no, this is dummy. Let's see. If I have a data like this, a column in which something is uh, like okay, okay, first, second, third. If suppose it is, and then here it is math score, math subject score. So here it is. Let's suppose 80. This is 71, and let's suppose this is 50. Now this is numerical. Machine can understand the numbers, but how about this? What about this? Machine won't understand the this one. So how to do? So for that, how to perform dummy? So this column will get converted into 3 columns. See, first record, and this is column first, this is column second, and this is column third. So here it is first in first record. So this one will become 1, rest all become 0. Second, so this second will become 1, rest all become 0. This third will become 1, rest all become 0. And here the math score will come 80, 71 and 50. Guys, understand? Anyone, is there any confusion in this? Okay. And there is something called this one, we can write it like this as well. 80, 71, 50. 1, 0, 0, 1, 0, 0. This is math score. This is first and this is second. I will not include this third. Automatically my model will understand if this 1 is here, it means it is first. If 1 is here, it means it is second. If both is not, this is something else definitely. This is not first and second. So this is the how you can decrease your dataset size. Okay. So this could be the another approach. So the first thing when we see it here, what we need to perform, once the data, we have to find the numerical and the categorical. So here in our case, those all are d types is also a function. You can check. So these all are completely numerical, so we do not have to change. First we have to divide between x and y. So what I will do here, our y is df of this mid. This is our y. Now x. So x is what? X is the entire column except the midway. So we can do it like this. Call in df dot columns. I'm using a for loop. If call not equal to medv. And now let's run this. Yeah, it ran. Now see x dot head. If I will do, see all the columns apart from the midway, and see this is our y. Okay, only one column midway. Is it clear till here? Now let's perform the train test split. So we have to import that from sklearn dot, I think, pre-processing import. Import. No, I think in model selection. Model selection import. Yeah, train test split. Now let's see. This is train test split. So let me copy it from the documentation. Okay, let me pass x comma y. It is open now, so I will just copy it from here. Yeah, this one. And we have to pass the test size. Test size equals 0.2 means 80% will be the train. And random state. Random state is just to make all the time data is same. Because when we will do this one, no, if you'll do split, so randomly it will take 80% of the data and the 20% of the data. But if I have used 248, so every time whenever I will learn, it will take the same 80% and the same 20%. It is not going to change. Now if I would check the shape of this, see the records are 12, and even here 1 2 3 4 5 6 7 8 9 10 11 12. These are the 12 columns. Only the number got changed, 405 404. If you check this df.shape, it has 506. So the 80% of the 506, if you will do 506 into 0.8, see this, almost it is coming 404. So this is how the 80% and the 20% got divided. Now we need to scale our data. So for that, from sklearn dot pre-processing import, let's suppose use a standard scaler. Okay, so first we have to create the object of the standard scaler. Okay, now okay, see here, how would we scale this? We have to scale our x train only. Remember that step. We have to scale our uh, scale scales dot fit underscore transform is the function in which we need to pass the x train, our x train data. See that it has a scaled. And do not confuse that why it is coming in the form of array. It is exactly same. I will show you. There's nothing change in that. See that it is same, only the values got scaled. Previously, what was the value? See that this value here, this is, so all in decimals, but you can see here 8.14. Now how much it is? 0. Only the value got scaled. Everything is same. This is structured everything. Okay, nothing has changed. So when I'm scaling it, I need to store it in a new variable. So just I'm giving a name, extend scale. Okay, now So there is an, what is it mean by there is a two functions, okay, and this is very 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 important, so try to understand this. When I'm imported this from sk learn dot pre-processing import a standard scalar, and here I created an object for that, a standard scalar, this object. So there are two functions from this. One is fit underscore transform and another is transform. So what they exactly do? So what is the formula of a standard scalar is x minus mu upon sigma. And let us suppose this is your extrain data. Extrain data, for that this one column extrain data. So this is 10, 20, 30 and 40 values are there. So there must be some mu for this, mu for entire data. Mu is the mean, whatever the value. I'm just assuming it is an 18 mu. There must be some variance for this. Variance I'm assuming it is an 3. Okay. So when you will do fit underscore transform, no, it will try to find it out the mean from here and the standard deviation from here. And then it will scale this data. Means on place of 10, what it will write? X minus mu is 18 divided by sigma, which is 3 on place of 10. And on place of 20, 20 minus mu upon sigma 3. This is on place of 20, on place of 10, on place of. So when you will do fit transform, it will find 18 and 3. But when you will do transform, and let's suppose in your X test, you have only two records like 30 and 12. Now, when you will do transform, again it will not find the mean and the standard deviation. It will use the same mean and the standard deviation from your trained data. Means on place of 30, it will write 30 minus 18 divided by 3. And 18 or 3 are mu and standard deviation from your trained data. Why? Because let me tell you the scenario. If suppose tomorrow you build the model, you build a model, and you build an application on website. Your model has trained it on your history, past data or the historical data, and now someone give some values here input, and you have to give you the output. Okay. So in that case, again, every time you are not going to scale these all. Like you will not find it out the mean value. If there is an only one value, like your model depends on the 4 columns, and they are giving only one value for each. How would you find the mean and the standard deviation for one value? You will not. So you have to use the mean and the standard deviation from your trained data. Okay. And by using this trained data, the mean and the standard deviation, you have to scale this and you have to give the output. Okay. Now let's see it here. So in terms of the scaling of X test data, X test, I will use here only transform. That's it. And we do not have any categorical to make it an embedding. But just to show you guys, let me show you anything, some so that you can. Okay, we'll show it later. Just understand now. Scaling we have done. Now we have to go with the model building. From sklearn dot linear model import linear regression, and this is the model name, and then I'm writing here linear regression. Okay, and now here I'm doing model dot model dot fit. Yes, oh, fit, and I have to pass my x train comma y train. So I fit the model. Now if you want to check what is the params of that, what is, no, there is something fit interest. Yeah, I think it will not give like this. No. So the intercept is your in y equals to mx plus c. This is the c value, and there is an coefficient. See that how many coefficients are coming. It depends on the number of column, because for every number of column there will be coefficient. Because it will like this. If suppose you have a 1 2 3 4 x values like columns, call 1, call 2, call 3, call 4, and call 5. So your equation will like this, 2 into call 1 plus 3 into, I'm just taking 2 and 3 just random value, 3 into call 2 plus 1.5 into call 3 plus 0.2 into call 4 plus c. The c is the intercept, which came, we saw that 34 or something here, this 37, and this is here. Okay, now we need a prediction. So model dot predict, model dot predict, and for the predict we will pass here x test, and so I'm saying here and giving a name y test underscore pred is the y test predict. Oh, mm, okay, now I got this y test prediction. Now I will check what is the error. So from sklearn dot matrix import mean squared error. Uh, okay, let's take mean absolute error. Fine. Now to check mean absolute error, if you'll do here, see it is saying y true and the y predict. So your true value and your predicted value you just pass. So what is the true value is the y test. There's the truth value, and the predicted value is y test predicted. So when I will do here, so it is a mean absolute error is coming 3.36. So this is the how my model is performing. Okay, now what is the error? Error is your y test minus y test pred. This is the error. Your actual minus predicted, and you have to uh, plot this the error. You need to check. Plt dot histogram was there. Let me see this. So if you can see it here, this error, actually it should have come normally distributed, but it is not exactly normally distributed. There is an, it is somehow, but there are some values it is going it here because there wasn't some outlier in the features. Okay, so that we have to check and we have to do further pre-processing to make it better. So I just want you guys to make this better. I'll share this notebook with you guys. Just go through this and make the performance better. Just like mean absolute error, try to decrease that error as much as possible. Okay, and if you want to see model dot adjusted r square, so there isn't something called, we'll see. Okay, there is a matrix In that adjusted R2 score. So R2 score is also there, which is important for the linear, which I had even told you guys. So y true and y predicted you can pass. It will tell you that what is the R2 score. Okay, so this is, let's see how much it is. So it's 76%. It is not bad, but not that much good. It is decent. Okay, so we can try it with the bit the different model, but I want you guys to try the linear regression and just show the result that try to increase this value, this R2 score, that how better you can do. And if you want to save this, just you have to click it here, save version. Okay, this is the version all, version 1, and you can just save it here, and it will save the version. You can see it here, it is saving. Okay, so this is how you can do. Okay, any question? And then please, if you guys will not do by yourself, then do not expect it. It is going to be a completely a problem for you guys. You will not able to code. Okay, so try to do it by yourself. Okay, that is the only way to improve yourself.